Hello again, so welcome lesson 3. This is a very small but very important part of chemistry because of course science is a practical subject and a lot of the things we do in the lab we really do need to be able to explain them extremely precisely and accurately and know what those words mean. So this is 4.3.1.4 in your book and it's in your quantitative chemistry booklet that I gave you, and it's about chemical measurements. Okay, so when we're taking chemical measurements, you cannot give an exact measurement. The degree of accuracy of your measure will always have an element of uncertainty. Now, the definition of uncertainty is the amount by which a given result may differ from the true value. All right, so how much it differs from the true value. Just that definition should have joggled your memory, okay? Because if you remember the the word from the syllabus, accuracy, actually means how close it is, how close your measurement is to that true value. So when we look at uncertainty, it is a measure of the accuracy of our results, okay? When you're looking at doing a practical, you need to choose appropriate measuring equipment. There is no point using a huge measuring cylinder to measure a tiny volume of liquid. You know that practically, that will not make sense. And the other way around similarly, because you have to keep refilling it. And every time you do, you're introducing error, okay? That would be systematic error if you had that's wrong size of measuring cylinder specified in your method, okay? So you've got to choose the appropriate measuring cylinder. But even then, we need to know that we can only measure to the accuracy of the smallest gradation on that measuring cylinder, the resolution, if you like. So if this measuring cylinder measures to 1 milliliter, okay, then we have an equation which will show us how accurate any measurement will be. It's that smallest division divided by 2. So let's look at what that means in reality. In reality, let's say we measure something at 6 millilitres, then the accuracy of that measurement of 6 millilitres will be to 1 millilitre, the smallest measure, divided by 2, or 6 millilitres plus or minus 0.5. Okay, if you think about it, that makes sense. With your measuring cylinder, you can only judge whether your bottom of your meniscus, which is where you're measuring from, at eye level, is halfway above or halfway below the gradation on the measuring cylinder. Anything else is not a true measurement, okay? So that is the measure of accuracy I want you to get used to using in the lab, okay? You do also need to know this formula for group data, that if you have a group set of data, the percentage uncertainty is the range in measurements in the group divided by the mean times 100%. So let's just remind ourselves what that would mean. The range of measurements is the difference between the highest and the lowest measurement. So in this instance, it's the difference between 0.1 millilitres and 1 milliliter. So that is 0.9. The mean, we know, we work out by adding up all the different values and dividing by the number of values. Okay? And then you multiply that by 100%, and that will give you a level of accuracy for your whole class data or your group data. But this is the one you're more likely to have to use in the lab. Just to go back then to remind us, uncertainty, the amount by which it differs from the true value, okay? That is not the same as precision. Precision means how close all the measures are to the mean. So that's where you think about your dartboard and think about all your measurements being clustered together, all right? So good. Hope you come away with an understanding of uncertainty and that there is always uncertainty, but as long as you quantify it, that's all you need to do in chemistry. So small bit of learning, check that out in your quantitative science booklet that I gave you, and hopefully see you soon. Bye.